Okay, so good evening, everybody, and let's get started. So, this is fifth week of, discussion on fifth week of content of this course for financial mathematics, and basically there were various methods of comparison that were discussed, and then there was discussion on project balance, etc. So, we'll talk about those things today, majorly, and you know. Mm, so this methods of comparison basically uh, it is used when you have uh, audio is on, no? That's what I was checking. Anyway, yeah. So let's say you have you're building something, some project is there. For example, something like nowadays these metros are coming in various cities or various places across our country. So sometimes you have to uh, decide whether putting a metro in a particular place is financially feasible or not. That this is just an example. It can be applied to any other case scenario. For example, if you want to start a business or something, let's say you want to open up a restaurant somewhere, uh, and then you have to guess like how much monthly income you would generate from that. Uh, let's say for next 5 or 10 years, and based on that, uh, you have to see how much initial investment that you need to put in. If you have your own capital, then not much to think about. But if if you are borrowing it from, let's say, bank or some other source of lending, then you have to think about how much interest as well as the principal that you end up paying at the end of the term of your loan, and will you be able to recover that much amount if you open up that restaurant. Or in the case of metros, uh, essentially it's very initial capital intensive kind of endeavor. So it's like thousands of crores of rupees are required to build a metro line across the city, uh, because it has a lot of things are there: land acquisition, then construction, and then maintenance. Then you have to hire a few people to take care of everyday operations. Okay, so you have to consider all those expenditures, and the revenue that will be generated is the passengers' fare that you will be collecting over the period of you know let's say at least 30, 40, 50, whatever number of years, because these metro kind of projects are uh, primarily for public service, and they are designed for a longer time horizon. So that's why the loans that you take or the government takes for such projects are usually at low interest rate, because the durations are quite large. And in case of restaurant, your own restaurant kind of example, the loan period will be shorter, because the amount will also be shorter. So you know uh, those kind of scenarios are there. So for example, if you want to open up a restaurant, and now you have done certain basic market survey, and now you have two places in mind where you can open the restaurant. So now the question is, where should you open it? Okay, so uh, this is the dilemma, right? So there you need to use these methods of comparison. So based on the particular location, how much footfall will be expected, how much expenses will be there, all those things you need to consider for next at least 5-10 years. So that is typically called as project life in this course terminology. Okay, and accordingly you have to take a call, because everybody thinks like, if you open up a restaurant in a posh place or in a crowded area, the chances of getting more customers is higher, but at the same time your expenditures also go up, because the demand is more for place, shop in that place. Okay, so like that. So that's why we study these different methods of comparison. Okay, so let's start the discussion. But I hope you understood the broad background that we are supposed to follow before studying these things. Okay, so yeah, so let's discuss about methods of comparison. So I'm not writing the full thing, that methods of comparison of feasibility of financial feasibility of project, that is understood. So first method is called as a present worth method. Okay, so this was given in the slides also, so I'll just briefly discuss about them, and then you know maybe we'll take some simple examples and then we'll go next like that. Okay, so we'll first finish all the concepts, and towards the end of the class we'll take some problems also. So the first one is present worth criterion or present worth method, whatever you want to call it. Usually they use PW as the short form for this criterion. Okay. So basically what it means is, let's say maybe we can understand this with the help of some diagram, simple cash flow diagram. Okay, so let's say this is your starting period for a project. Okay. Okay. So let's say on time axis you have uh, number of years, let's say, and then maybe you can use some different color for different type of expenditures. Okay. So let's say you have initial investment or some initial cost that is required is minus P, and then once you put that cost, let's say you start generating revenue for from next year. It is not necessary that you will start generating revenue from next year. Okay, it is all a function of your uh, kind of what kind of business model you have. All those things are there, and these are like net quantities. Okay, it's not like only you will get uh, you know profits from year one. Let's say in this case we think like we'll get some profits, so that is net profit. So that means whatever expenditures you had, those are smaller than the revenue that you generated in that year. Okay, so that is why these are on the positive side. Okay, so let's say something like this. So uh, what this, and maybe we can represent these things like you know F1, F2. These are just symbols. This will be Fn. Okay, so this is a typical cash flow diagram. It can be, there are various types of cash flow diagrams also. Something like this thing, right? Equal payment, etc., equal revenue, etc., that we studied previously. Or then there will be recurring kind of thing also is there, that every year you get, or every 2 3 years you get the same pattern. Okay, so this is applicable for cyclical businesses mostly. Okay, but the main idea is, if you have such a cash flow diagram, the present worth criterion is nothing but whatever values that you have in the future. Okay, so basically you stand at this point, which is your initial point, and then you discount all these future cash flows back to the present time. Okay, so for example, in this case, so how do you discount them? We have studied this, right? So basically this present worth for all these cash flow given in this image or the sketch will be nothing but, whatever revenue that you generate, or the discounted values of future cash flow discounted back to the present value, which is at the start. Okay, so basically at the present time. So that will be nothing but, you know you have to multiply this f1 by p by f, whatever interest rate that you have, and n. So n in this case will be 1, plus f2 p by f I 2. Okay, so on and so forth. So the last fn into p by f comma I comma n. Okay, so this I can be variable also. For a particular time period you will have certain I, interest rate per annum, or during the later half of your project life. So this n is also called as project life. So these are common terminologies that are used. So I can be different. Okay, so here I am assuming that it is the same I, but not necessary. So I can be different also depending on your case study. So this is your all the future values discounted to the present time, and then you need to subtract the initial cost that you put in for this project. Okay, so this is your present worth. So in present worth criterion, basically we do this calculation. So whatever cash flows are expected in the future, you discount them back to the current price. Okay, and if you do this calculation, you will get a number. So there could be 3 cases, right? So depending on these calculations, or okay, so this is nothing but, the first bracket is nothing but discounted cash flows from the future, and P is initial investment, right? I'm not writing that explicitly, but I think you guys understood. I mean, this is also, we call it as receipts. So these are net receipts, this curly bracket, including all the F values, and P is the net disbursement at the n equal to 0 or t equal to 0 time. Okay, so there could be 3 cases, right? So if PW, let's say, is greater than 0, in that case, you know I mean, you should look at the number also, how large this number is. For example, if you're comparing two project ideas, if both of them give PW of greater than 0, then whichever is the highest or higher, that project is more feasible. But in general, there are 3 cases. PW can be greater than 0, or it can be equal to 0, or it can be uh, less than 0. So depending on which number you get after doing these calculations, this is called as economically feasible or acceptable option. Okay, if the PW is greater than 0, if it is equal to 0, then it is called as break even. Okay, so break even means whatever money you are putting, you are just about to recover that much only, no profits, but no loss also. Okay, and this is called as infeasible, or what do you call, not viable or not feasible. Okay, so this is how you should use this present worth criterion, and I mean, I'm assuming these factors. These factors you need to get them from different interest tables, because you know uh, this thing. What do you say? These are p by f factors for given I for different n values. So those tables are there. So we can take one simple example, since that will be easy to understand. So you have a project, in which uh, an investment of 50K, 50,000, but I'm writing 50K, generates cash flows or cash inflow. In this case, they have mentioned. So in our in our class terminologies, it is nothing but receipts. Okay, it's not disbursement, it is receipts of 20k per year for 3 years. Okay. Okay, at 10% discount rate. Is this project feasible as per PW criteria? Okay, so this is a simple problem. You can expect such problems in your exam also. So basically, here your P is 50k. So I mean, you can put negative sign also, but since we are taking it in minus sense, it is fine. Okay. And your F1, F2, F3 are all equal. They are equal in this problem, but not necessarily always they will be equal. Okay, so it can be any three different numbers or any n numbers, different numbers. I they have given 10%, and n here is basically 3 maximum. Okay, so no need to write that because it is understandable. Okay, so the present worth for this whole project in a 3 years project life would be F1 into P by F 10 comma 1 plus F2 into P by F 10 comma 2, and similarly F3 P by F 10 comma 3 minus P, right? So now if you remember P by F formula that you can use, that will be nothing but 1 by 1 plus I power n. Okay, but if you don't, you should use the interest rate tables also, that is also fine. So these were given in this class, right? Let me just check. Okay, so we have I equal to 10, right? They have given for 6, 7, 12, but not 10. Let me just check if any other place. 15 is also there. 8 is there. 10 is also there, but it is in the another class, third class for week 5. Anyway, so P by F 10 to 10 1 is 1.1. Okay, so this will be F1 is 20 and P by F is 0.9091. Okay. F2 is also 20 in this problem, and 10 2 is 0.8264, and 10 3 P by F 10 3 is 0.7513 minus 50. Okay, so I'm not writing that k, okay, 10 to the power 3 because that is understood. Okay, so if you do this, what would you get? Let me just check what is the PW value in this case. So we can take 20 common from the first 3 terms, then just add those factors. 0.9091, 0.8264, 0.7513. So it comes out to be 49.736 minus 50. Okay, so it is minus 0.264k. Okay, this k you understand, right? It is 10 to the power 3. So now the thing is, this PW is less than 0, therefore this project is financially infeasible. Okay, because at the end of 3 years your net present value, I mean not at the end of 3 years, the whole cash inflows discounted to the present value up to 3 years are would be giving you the present worth which is negative. So therefore this is not a good thing to pursue. Now, in some cases, what happens? You can't just go by the economics or the maths, because let's say if you want to put up a metro project in a city, uh, the thing is, uh, these metro projects, etc. They are for a longer time frame. Let's say 20, 30 years, right? So you don't know what will happen in next 20, 30 years for for a given city or something like that. For example, if you consider Bangalore, uh, you know, like 30 years back, nobody expected Bangalore would be looking like this after 30 years, right? So first of all, there is some guesswork when you guess future cash flows or receipts or disbursements, whatever you want to call it. So usually, when the projects are for common good or public benefit, in that cases, even if they are, you know, not that much financially feasible, they are made feasible by reducing the interest rate or discount rate, whatever you want to call it. Okay, so that's why this metro projects, if you check the financials, I don't think the interest rates or discount rates are 10%. They're usually like 1 or 2% or max 3%, something like that, but for longer time. And since these are common good projects, they are like that. Okay, they are not for profit basically. Okay, anyway, so that was a side note. So this is how you use present worth criterion. Then there was a second criterion, which is nothing but called as annual equivalent criterion. Okay, annual equivalent criterion. Okay, so as the name suggests, in this case, what you do, whatever your uh, inflows or cash receipts and disbursements are there, you basically bring everything, uh, you know uh, like all these cash inflows, outflows, and you convert them into equal annual cash flows over the lifespan of the project. Okay, so uh, you know this is good for comparison if there are different projects with different lifespans and different cost structures. Okay, so here also decision rule is more or less same, only that if AW is greater than uh, sometimes it is also called as annual worth. Okay, so this uh, in some places you may see this as AE or AW also. Doesn't matter as long as you know what is what. Okay, because in the slides that were shared for the or the PDF that was shared, there is AE and AW also. So these things are more or less same only. Okay, so basically you calculate the present worth for all of your future cash flows, and then you convert them into equal annual cash flows, okay, for the lifespan of the project. Okay, so basically what you do here is this AE for given interest rate is nothing but you calculate present worth by the first method, and then you multiply by uh, A by P I comma N, if I'm not wrong. Just check. Yeah, and this factor is, if you don't remember, it is nothing but I into I plus 1 power n divided by I plus 1 power n minus 1. Okay, so you can go back and check that. So basically here you are spreading your present worth over the lifespan of the project in equal payments or equal cash flows. Okay, so this is useful, in particular cases. For example, uh, it is useful for repeating cash flows. Okay, so one useful for repeating cash flow patterns. Okay, so one problem was taken by professor also in the class. In that case, it becomes easier to understand. Okay, if you have basically this is like EMI. For example, if you are taking two types of, like if you want to take a home loan, uh, or maybe multiple loans in the future, but you are not sure which bank you should go to. Different banks will charge different interest rates, but you know there will be some other perks or benefits also there, right? So in those cases, whatever future uh, inflows or outflows are there, you convert them back to the present by discounting as per the first method, and then you convert everything in terms of EMI or annuities, what they call, and then you see which EMI will be better or lesser, like that. Okay, so that way you should use this annual worth or annual equivalent criterion. Okay, so that is one thing. Mm, Let me just see one thing before we move on. Yeah, so you know uh, you should refer to the one problem that professor took in the class where you have a repeating pattern. I am not doing it again because it's same thing doing again and again. But we can do similar kind of things. Okay, so maybe we can take one problem. Let me just look for it. Mm, okay, so uh, so basically, let's say you want to take a vehicle loan. Okay. Mm, so maybe this kind of problem. Okay, so you want to buy a car, for example. So, but you can pay like half of, let's say, 10 lakh or 12 lakh car, typical middle class kind of example. I mean, you can take anything you want. This is just an example. Don't look much into it. Okay, so now you have two options. Okay, uh, two options for a vehicle loan. Okay, so let's say option A is 4 lakhs of rupees at 8% per annum, compounded annually for 5 years. And second option that you have is 5.5 lakh rupees at 10% per annum for, let's say, same 5 years tenure, project life or project tenure. So both of these are within your budget. Okay, if you want to buy 10 lakhs of worth of car, uh, some down payment you will do from your savings or something like that. So remaining, you want to see which this thing is important. Okay, I mean, which uh, which one is better. Okay, so in this case, you know, so basically what you are doing here is you are calculating the EMI using. I mean, you can consider it like an EMI. So basically, you are taking this much principal loan, right, at this much rate for certain duration, and then how much EMI you will get. Okay, so in that case, let's say for option A, uh, your AE or AW also you can write will be nothing but TW into A by P, 8%. for 5 years, something like this, right? Uh, okay, so now I mean this present worth, it's today only you are taking the loan, right? So this is like PW is given here only. So for this present worth is 4 lakhs. So maybe I'll write 10 to the power 5. Now A by P 8 and 5. Okay, so for that you need to use the charts. Okay, so 8, for 8 do we have chart? It is the question. Yeah, we have 8. So A by P 8 5. Okay, so A by P 8 5. So that will be 0.2505. Okay. So I think it is around 1 lakh, but let's do the maths. Yeah, it is 100,020. Okay, so 1 lakh 200. Okay, so this is your uh, EMI basically per year basis, because your interest rate is per year. Okay, and in option B, if you go for this EMI, whatever EMI that you get, that will be 5.5 into 10 to the power 5. So this will be A by P 10 5. So A by P 10 5 comes out to be 0.2638. Okay, so how much that will be? 5.5 0.2638. It comes out to be 1 lakh 45,090 rupees. Okay, so now you need to take a call. Okay, uh, so whether you can pay 1 lakh EMI per year. So you can divide this in 12 equal intervals. That will be your EMI per month or installment per month. Okay. So like that you use this AE method to compare the compare two options. Okay, so here neither of A and B options are bad or infeasible. Okay, it depends on your own condition. So if you can manage to pay 1.45 lakhs per year, uh, then that is also feasible. But if you can't, let's say your constraint is that you can only do 1.2 lakhs per annum, considering other expenses that you have, then you have to go for option A only. Okay, so like that. So this is one more application. Another application could be, let's say you are starting some project, and then again you have to decide the feasibility. So that is like typical problem that we discussed previously also, right? Okay, so you know, for example, uh, initial investment for certain project is, let's say, 1 lakh. Okay, I'm not writing the whole text because that takes time. So, but you get the idea, right? It's the same language that we used previously. Okay, an annual cash inflow that it generates after the uh, first year, after 1 year, is around 30K, 30 lakhs, 30,000. Okay, and project life is 5 years, and interest rate is 10% per annum. Okay, if it is not mentioned per annum, then it is 10%. Usually it is in annual basis only. So here you have to determine uh, feasibility of the project using AE method or AW method, whatever you want to call. Okay, so this is a typical application. So here, what is your AE? For that, first you need to find the PW, right? Present worth. Okay. And how do you do that? You have to discount for 5 years. Uh, this thing, right? So basically your uh, cash flow diagram looks like this: one, two, three, four, right? Zero, one, two, three, four. One more will be there, no? One second. Yeah, one more will be there, right? Like this: zero, one, two, three, four, five. So this is minus 1 lakh. This is 30k, 30k, like that. Okay. So one thing is you can do, for every individual 30 by 30 into this and that. But one another shortcut that you could use, which we professor also used this one in some problems, is nothing but you know you convert this EPS series back to the present worth by using that uh, A by B formula, right? So basically, what I'm trying to say is, uh, you know, see, what I'm saying is, one way is to do this by F by P I1 plus 30 F by P, oh sorry, F by P I2, so on and so forth. Then you'll have 30 F by P I5 minus uh, 1 lakh will be 100 here. Okay, we are talking about thousands. Or you can do one thing also, instead of writing the whole thing, you can do, or both will be giving same answer only: 30 into F by A I comma 5 into, this will be your future value, right? Then you have to discount, right? So this will be P by F I 5, and then you subtract initial investment from this. Okay, so this also is possible. uh, P by F only, right? This is P by F, sorry. Yeah, yeah. Because these are all future values now, so denominator should be F. And in this case, this is the future value for given A, so this is fine. And yeah, so here also it should be, this is your future value, and then you are discounting it back to the original, so it will be P by F, if I'm not wrong. Okay, so both should give same answer. So let's see. Here I is 10. Okay, so let's calculate using this method and see if it is matching with the first one. So you have 30, this F by A 10 5. So we need to see the table for 10. Okay. F by A 10 5. F by A 10 5. So that is 6.1051 into P by F 10 5. P by F 10 5 is 0.6209 minus 100. So what is this? 30 into 6.1051 209 minus 100. So this comes up to be 13.72 K. Is it correct? That is the question. or we could have just I mean, we could have just used that formula, no, between A and B, right? So yeah, I think there is no need to do this way. Here it is a simple problem. What we could do is 30. So we will just convert it back to the or discount it back. Now these are all the A values. So that will be P by A into I comma 5 minus 100. Okay, so P by A I comma 5. P by A I comma 5 is 3.7908. 30 into 3.7908. Yeah, it's actually the same answer only. So that is 113.724 minus 100. So that is 13.724 K. Okay, so 1000 it will be. Let me just see. If we do it by the first way, how much will you get? Okay, so this is your present worth, right? One second. By F. I'm just checking if I do it the first way, am I getting the same answer or not? So hold up. Just give me a second. 9091 plus 8264 plus 7513 plus 6830 plus 6209. Yeah, so basically it's I just checked both the ways. If you do that is fine, it will give the same answer. But the thing is, you're not supposed to calculate PW, right? You are supposed to calculate AE. So for that you need to use this PW into this formula. So AE will be PW into A by P 10 comma 5, right? So that is nothing but 13.724 into 10 to the power 3. A by P 10 5. A by P 10 5 from the chart is 0.2638. Okay. So what does that mean? That means 13.724 into A by B 10 8. 10 5, sorry. 0.2638. It comes out to be 36.4 INR. Okay. Did we do any mistake? Let me just check. One second. A is coming out to be 30,000 in this case. Is the PW. One 113.7327. they are not subtracting 1 lakh. Let me just see the solution. There is some mistake here. Uh, in the solution, they are not subtracting in the present worth. Uh, they are not subtracting this. Okay. So that's why they are getting that answer. But that is wrong, na? Because you have to subtract that, right? Yeah. So, yeah, I mean, what I'm trying to say here is the solution that I'm looking at, they are not subtracting this 100,000 from PW. So only PW that they are getting is 113, and then they are calculating E for that. But that should be incorrect. No? Just check. So now it makes sense. So since this is greater than 0, oh, it is economically feasible. Okay, so that kind of this thing is always there. So this AE, PW, or even FW is greater than 0, then it is worth pursuing like that. Okay, so let's move on to the third one, which is one is PW, second is AE or AW. The third one is nothing but whatever is in our common context, whatever is remaining, that is future value, right? So that is that comes under the title of or the heading of future worth comparison. Okay, so I think by now you would have understood what this means. Is basically instead it all depends where you are discounting your cash flows at. If you are going to the future, I mean, if you are discounting them back to the present, that is PW. If you discount them back to present and then you take the a equal EPS formula, then it is AE method or AW method. If it is the last one, which is future worth criterion, so as the name suggests, it will be FW criterion. So in this case, what you do, you basically uh, convert the present worth of your investments at some future time. Okay, so not only present, all the cash flows that you have, plus minus whatever, you convert them to the future value at particular time in the future. Okay, so that is what future worth method is all about. Okay. So let's take one simple problem on that also. Okay. So why do we do that? Because in some cases it may be useful to see the final worth of your investment at specific point in your future. Okay. Um, okay. So in this case, what you basically do is, like you can do one thing, you can discount all the cash flows to the present worth, and then you project that present worth into the future. So what I'm trying to say is, you can do both ways. So you can calculate future work by calculating present work and then projecting into the some future that you want, okay, after 10 years or something like this. Or don't calculate present worth at all. What you can do is you can just you know whatever cash flows that you have, you just project them directly into the future. You don't no need to calculate uh, this thing, present worth. So take individual cash flow and calculate the future value according to the remaining time between that cash flow time and the future value of future time of your interest. So you can do both ways, whichever is easier for you to do. Okay. And here also, if MW is greater than 0, it is economically feasible. If it is less than 0, it is infeasible, equal to 0, break even. And in some cases, they want to compare the two options. Then whichever FW is higher, that will be a better option. Okay, so this kind of problems you can expect. Okay. So this is sometimes written as F by P also. F by P comma I comma N. Same thing only. So maybe we can take one problem on this also. We'll take some simple problems so that you understand the concept. Uh, One second. Yeah. So let's take this problem. Okay. So initial investment for a project is 50,000. Okay. And it generates cash flows. Cash flow for year 1 is, let's say, 15K. Cash flow for year 2 is, let's say, 20 or 25. And for year 3 it is, let's say, 30K. Okay, so it is generating more and more cash every year. Okay. And then you take interest rate of 10% per annum. Then you need to determine the feasibility of this project based on FW criteria. Okay, so straightforward example, but you can expect these type of problems also. Okay, so here what you basically have to do is project everything at the end of year 3. Okay, so how do you do that? One thing, as I said, you can calculate all the present worths. I mean, for all these cash flows, you can calculate their present worth at, let's say, t equal to 0, or you can calculate individual uh, inflow or cash flow value at the end of 3 years. Okay, so let's do one by one. Okay, so um, FW, okay, so total future worth. Let's say let's take the 50K one. So 50K, that is at the start of your project. So after 3 years, what will be its future value? So that will be nothing but this is your P, right? So you want F, so it will be F by P 10 comma 3, right? Because this is your P value, you need to convert it into uh, future value. So F by P ratio will be in the bracket, and it will be minus because this is a disbursement. Okay. Then there are cash flows, inflows are there for 3 years, next 3 years. So this will be 15, and again this will be F by P 10 comma 2. Then this 10 comma 2 comes because only 1 year has gone, right? So only 2 years are there, so you have to calculate future value only after 2 years. Similarly, 25 F by P 10 comma 1 plus 30. 30 will not have anything because it's at the end of year 3. So at that point we are trying to get all the values. Okay. So now you have to follow the table. So this is minus 50 F by P 10 3. So let me just see the table. So I'm using the table given in the class only, right? So nothing fancy I'm doing. So F by P 10 3 is 1.331 plus 15 into F by P 10 2 is 1.21 plus 25 into 1.1 plus 30. Okay, so let's find these values. Okay, so 30 plus 25 into 1.1 plus 15 into 1.21 plus minus 50 into 1.331. So it comes out to be 9100 INR or 9.1 K also I can write. Since it is greater than 0, it is a feasible project. Okay, so I mean, you can guess it, right? Because the cash flows are becoming more and more. You can solve the same problem, and instead of, let's say, in year number 3, instead of 30K, you would have only gotten, let's say, 20K. So in that case, it would have become infeasible project because that will be summation will be minus 900. Okay, so depending on how much cash flow they are generating, etc., the same project could be becoming feasible or infeasible. Okay, so like that. So you can't just say this project is feasible or not based on just their this thing numbers. You have to do calculations, then only you will say for sure. Okay, so these were these 3 criterions. Okay. Then there was this uh, important note was there because you may see some problems like this. If you are comparing two uh, alternatives A and B, the ratio of their present worth, future worth, and this AE or AW is more or less equal. Okay, so they may ask you some ratios also, something like that. We did one problem, right, like this vehicle loan wala thing. So here the ratio of AE will be 1 by 1.45. So that will be true for PW and FW also. So like that. Because in the end, you are calculating everything from PW only by multiplying certain factors. And as long as those factors remain same, okay, so for this to hold, I and N must be same, okay, for A and B alternatives. If I and N change, then you can't write this. If I and N are same, you are basically multiplying PW by same factor. So that is why their ratios remain more or less same only. Okay. So this one you can keep in mind because they may ask some ratios later on. Okay. So this was one of the problem, one of the important note that you should remember. Then there was a discussion on internal rate of return. Internal rate of return, IRR they call. Okay. So you know this is, if you want to just remember in one line, it is I star for which the PW comes out to be 0. Okay. So in the first method we calculated PW, right? So there will be some interest rate I star for which this PW will become 0, and that is called as internal rate of return. So it also means that equivalent values of your receipts will be equal to equivalent values of your disbursements, all discounted back to the present worth. Okay. Now the challenge in this case is it's not easy to solve such problems. Okay, you have to use hit and try hit and trial or any numerical methods, because this becomes non-linear equation. Okay. So what I mean by that is, let me just uh, see. There was one problem looking at WC. Second. Where did that go? IRR. Basically, if you expand this equation, it will be nothing but um, you know this summation of no need, because it may again confuse you. Maybe we should take one problem and then uh, try to solve this. But as I said, it's not that straightforward. You need to use numerical methods or hit and trial, or there are now even calculators, financial calculators in your MS Excel also, Microsoft Excel also you can use. Okay. Or you can write a Python code and it can iteratively solve. Okay, so one thing that you should remember is, we'll take one simple problem also. Uh, but if we calculate this I star, so if this IRR, which is nothing but I star, is greater than your cost of capital, then this is a profitable or feasible condition, or profitable or feasible project. Okay. Otherwise, if this IRR is less than your cost of capital or desired return, then it is a infeasible project. Okay. So otherwise it is unprofitable. Otherwise infeasible. So sometimes I don't think it will be asked in your syllabus, because you need different, or you can't use the simple calculator to find IRR, because it's a non-linear equation. But maybe later on somewhere it may come in handy, that they will ask you to first find IRR, and they will ask you whether this is a feasible project or not. Determine that based on your uh, IRR calculations. So then you should ask, what is the cost of capital that I am paying, and if my IRR is greater than that, then it's well and good. Otherwise, this project should not be pursued further. Okay. So one question that we can take is, you know. Uh, Suppose we invest 10K today and it returns 4K per year for 3 years. Find IRR. Okay, this is a simple problem. So here the thing is, you need to first find the present worth. Okay, so you know since this will be negative, I'm not multiplying by 1000 everywhere, otherwise it becomes confusing because in the end you are going to equate it to 0 only. Plus first year, if you discount it, basically, you know, it is going to be this is future value, right? We are getting it back to the uh, present value. So this will be I star 1 plus 4 P by F I star 2, and third year will be correct. Yeah. Now the question is, since the I star is not known, you can't use the tables. Okay, so you have to use the formulas. So for this, the formula will be 1 plus I star power minus 1 plus 4 into 1 plus I star power minus 2 plus 4 into 1 plus I star power minus 3. Okay, so now you see this is not that easy equation to solve because it's a nonlinear equation in I star. Okay, so you have to use hit and trial method first of all, or what you can do is maybe take some guesses. Okay, and this PW uh, has to be equal to 0, right, to find I star. So you have to equate this equation to 0. So in other words, you know what you need to do here is, um, you can take 1 plus I star power 1 minus 1 common, then this will become 1 plus I star power minus 1 plus 1 plus I star power minus 2 equal to 10 by 4, that is 2.5. Okay. So something like this you have to do, but it's still not easy to solve. So you have to use hit and trial method or iterative solvers. I'm not, I mean, I encourage you to find a solution for this, but it has to be done. Or nowadays there are, as I said, there are direct calculators, or in Python, etc. You can use this IRR library also is there. So directly you have to just give the cash flows and it calculates IRR. Okay, so those things are there, you know, and if you do that, you should get 9.70%. Okay, so you can verify this, but there is no straightforward answer to this. Okay. So yeah, so this is now you have to check whether this I star, if it is greater than your cost of capital, then it is okay. Otherwise, it's not a good or feasible project. Okay, so like that, you have to take decisions in these cases. Okay. So this was regarding your IRR. I don't expect any difficult problems about this in your exam, but still, since it was discussed, you should be uh, aware of how do you go about it. And then after these three methods, there was discussion on payback period, right? So as the name suggests, when you do any investment, uh, you know, you want to know in how much time will your investment be uh, this thing, returned to you, and then after that, how much profits that you will uh, generate out of your investment. Ideally, it should be the payback period should be as small as possible, so that the capital that you put is quickly retrieved, and then you enjoy the profits. Okay, uh, that is one thing. Okay, so payback period. So I'm not writing definition again because that is discussed in the class, which is in notes also. But there are two cases here. I mean, uh, first option is without interest. Okay. So whatever capital that you have put in a project, you are not putting any, or you are not getting charged any interest for it. But many a times it is with interest, because the capital required for your investment may be not available with you. You have to borrow it from somewhere, and then you need to pay interest on that. Okay, so depending on those things, you have to study. Okay, so this one is easy because when you don't have any interest calculations, what you essentially put initially, you just have to retrieve that much back, okay, without any interest, etc. So if you put 10K today, let's say it gets back in, year one you get 5K, year two you get 4K, and year three you get 2K. So by the end of year three, your whole capital is retrieved. You have profit of 1K. So that is your payback period. Okay. But this case where your interest is charged, this is the trickier case. So you should be careful about this, and most likely this kind of things will be asked in your exam also, or in your assignment also. There could be something like this. Okay. So let me just see about that. Uh, you know, so basically, when interest is there, you consider the time value of money, and then it is the length of time required until your equivalent receipts exceed the equivalent capital outlays. So equivalent means you have to discount them to the present worth, or whatever you want to calculate. But usually we discount them back to present, okay, or t equal to 0, something like that. Okay. Maybe we can look for some problem. Give me some time. Okay. So we'll not take this case because it's understandable. We'll take some other type of problems. Okay. Mm, Okay, so maybe we can take one problem, but it's nothing but the same thing. You are just converting your future cash flows to the present worth, and whenever, like, just you need to know the point where it crosses uh, your this PW becomes greater than 0. Okay, so that is your payback period. So maybe you can take a problem like this. So I'm not writing the whole thing, I'll just give you a table, end of year, and then you have cash flow, let's say in thousands. Okay, so initially, let's say you put some 80,000 rupees. This is a problem of a purchase of a machine. So you purchased a machine at 80,000, and at the end of 1 year you get 25k out of operating that machine, net profit. Okay, then you get 30, 20, and 15. Okay, so like this. So you need to find find payback period, assuming interest rate of 10%. Okay, so here what you do, basically you have to take all these cash flows and discount them back to the present worth. Okay, so I would say PW1, which is nothing but present worth at the end of, I mean, till the year 1, whatever is cash flow, we are discounting it back to the present worth. Okay, so there it will be 80 plus 25 into P by F 10 comma 1, and you have to see if this value is greater than or less than 0. Okay, so this factor comes out to be P by F 10 1. Okay, P by F 10 1. 10 1. So 0.9091. Okay, so I don't think it is becoming greater than 1. Okay, just see 25 into 0.9091 minus 80. So it is still minus 57.27. Okay, so 25. Okay, so it is still less than 0. See, PW0 is minus 80k. Okay, so that is still less than 0. So we can't do anything. We have to stop when this becomes greater than 0. Okay, so one second. Yeah. Now if you calculate PW2, that will be minus 80 plus 25 P by F 10 1, and then you have this 30 P by F 10 2, right? So this value, first value, we already know it is minus 57.2725. Then you have to add this PF 10 2. PF 10 2 is 0.8264. Okay, so you have to add to this 30 into 0.2, 0.8264. So it is now minus 32.48. Okay, I'm rounding it off. So similarly, you have to do the calculations. If you do PW3, so that will add again this 30 plus, that 20 term. So 20 into That will be P by F 10.3. P by F 10.3 is 0.7513. So it becomes minus 17.45. Okay, so let's round it off to 2 digits. And then finally, if you add the final 15 Vara term, that is 15 into P by F 10.4. P by F 10.4 is 0.6830. 8. It is still negative after this also. Uh, mm, yeah, so there is some problem here. I think this last value is incorrect. Let me just check. See, if it is, no interest case, okay, so it is no interest case, then, maybe what I'll do, I'll change these numbers because then you can study both of these together. Maybe I have to change these values, but that's fine. So let's say it was 30 here only, and let's say 20 here, or maybe I can do ulta. Let's say this was 35, this is 20, and let's say this is 30. There's some random numbers I'm putting. So this is without interest. If you sum these three, it is 80. So payback period is 3 years. Okay, so that's why I said it is the easier case. But when you have interest, then you have to calculate this PW including each and every cash flow, and whenever it turns or changes the sign, that is your payback period, right? So that's what we are doing. Okay, so let me just see if I did any calculation mistake. 25 into 0.9091, that is fine. So take a second, I'll just delete this rest of these things. Okay, so minus 57.275 at the end of 1 year. Then you have to add, now it is 35, right? So this will become 35. I'll change this one. And PF 10.2. I should not make mistake if I'm seeing the wrong table. PF 10.2 is 0.8264. Okay. So plus 35 into 0.8264. So this comes out to be minus 28.3845. Okay. And then we have next one is 20. So we have to add 20 into PF 10.3. That is PF 10.3 is 0.7513. Okay. So this becomes minus 13.3225. And then finally this last 30 term, 30 into PF 104. PF 104 is 0.6830. 6830. So that becomes plus 7.1675. Okay, so therefore payback period in the case of interest with interest is 4 years. Okay. So by the end of 4 years, you will have certain, you will recover your initial capital, and then after that, whatever cash inflow takes place, or whatever receipts are there, those are your profits. Okay, like that. So this is about this payback period concept. Okay, so um, after that, there was discussion on this. What do you say? Uh, there were discussion on this capitalized equivalent and capital recovery with return, right? So those things were there. Uh, so let's see those. Okay. So this is called as capitalized equivalent amount. Okay. They were using CE acronym for that. Okay, so it is nothing but your present worth for n tending to infinity. Okay. So basically, it is called as perpetual project life condition. And they what they did tested basically. So then you convert this PW in terms of your annuities, and basically this becomes P by A for given I and infinite time periods. So if you simplify by putting this factor, what do you get is A by I. Okay. So uh, you know it's like you know uh, when your cash flows are repeated annually for like perpetuity or very large number of years, then in that case this A by I is rate of interest per annum. A is that EPS annuity term. Okay, so that represents equivalent amount to the net difference of receipts and disbursements when the cash flow pattern is repeated this thing in perpetuity. Okay, so that is the definition. We'll see couple of problems on this. Okay, so that it is becomes clear. Capitalized equivalent. One second. Okay, so I can give you a simple problem like this, where I will give you some cash flows, then you have to calculate. No need of giving cash flows only. I'll just give you the present worth of a particular project for various cash flows, and then given the interest rate, you can just divide by I and get the value. That's not the point. We'll see some problems after this, but before that, there is one more concept, right, which is capital recovery. Okay, so capital recovery with return. Okay. CR, I think, is the short form used for this. Okay, so this comes into the picture when you have some salvage value for your investment. For example, if you have put up a plant or something, then uh, you know in that case you consider initial cost or initial investment, and then the salvage value of your asset after certain uh, uh, lifespan, okay, of that project, and then you calculate the equal amount of annuities. Okay, so this is basically equal to, this CR is equal to equal annual cash flow over the lifespan of the project, that is equivalent to the capital costs for the investments. We take two capital costs, which is initial and the salvage. Okay, so this is CR is nothing but uh, you know P into A by P I N minus F A by F I N. Okay, so here basically this P is considered as positive, F is considered as negative, so that is a sign change that you should remember. So that is why this becomes, there is one step I'm skipping that, but you should go back to the class notes and see. So here you get something like this, plus Fi. Okay, so these are some of the things. We'll take a couple of problems on this. uh, you know and then there was a project balance diagram, etc. But that is nothing but these calculations only, these payback period calculations. If you plot them with respect to time, uh, then whenever you cut the time axis, which is usually the x-axis, that is your payback period, and then other references you can do. But basically, essentially, what you do is you take you know this this is your time axis, n equal to 0, 1, 2, 3, 4, like that, and you plot your present worth essentially. Okay, and then whenever usually it will be like this, right? I mean, I'm just giving you an example that is called as a project balance diagram. Okay, so it's not for this problem, but there was a class, in class there was a one example on this also, so you should follow that. But we'll take some problem on this CE and CR, so that is what I want to take mainly. Then we'll see. Okay. Yeah, this one. Actually, this is uh, yeah. So let's take this problem. So there is a project where you have initial cost of project as 12 lakhs, or maybe let's say 120 lakhs. Okay, so big project, 120 lakhs. Annual operating cost or annual maintenance cost is around 8 lakhs. Okay. And apart from that, project is expected to have one time major expense of 30 lakhs at the end of 14 years. Okay, so after 14 years there is a major expense planned of 30 lakh rupees. Okay, so this is information given, and you need to calculate capitalized cost at interest rate of 10%. This is a question. First of all, you should know what they're asking. So they are basically asking the CE amount, okay, capitalized equivalent amount or capitalized cost also they call. So, you know, now the thing is, how do you calculate that? Okay. So one thing is, here you have three costs, right? You have initial cost, you have annual cost, which will keep on recurring for and tending to infinity. They have not mentioned that it is only till 14 years. Okay, so they have mentioned there is one major expense after 14 years, but there is annual maintenance, or in some cases they will call it as annual operational cost, etc. But it is the cost that keeps on repeating on annual basis. Okay, so that is where this. Okay, so whatever A is there, this is nothing but A. Okay, so and the third cost is this 30 lakhs. Okay, so that is but at the end of 14 years. So basically what you have to do here is this, let's say this is your CE. CE will be nothing but whatever you need to put on the table today. So 120 lakhs plus this 8 lakhs divided by I, right? Because that will be, this will give you by the formula A by I, right? So A is 8 here. So 8 by I. I is 10%, so 0.1. So this number comes from there. This is a factor considering annual maintenance cost for n tending to infinity. So this much you have to keep in mind at the start. Okay. Now there is an expenditure. For example, this is your starting point. After 14 years, you have to spend 30 lakhs. Okay, so now we have to discount this value back to the future, back to the present. Okay. So how do you do that? You basically multiply 30 by this is your future value, right? So you have to multiply by P by F 10, 14. So that is the value that you need to consider it on your books today. Okay. So this is how you have to take into account all the numbers given in this problem. Okay. So if you do this calculation, this 120 remains as it is. This becomes 80. And this factor, now you have to look at the table of 10, and for 14 years you have to see the value of P by F. Okay, so P by F for 10% after 14 years is 0.2633. Okay, so now this will be nothing but 30 into 12633. That comes out to be 7.899 lakhs plus 200 lakhs. So the total capitalized equivalent cost today that you need to have or consider in your books is this much. Okay, so even if you are initially you want to put the 120 lakhs only, but considering the annual costs and one big time major expense, your equivalent capitalized cost today, the present worth of equivalent, all of your equivalent cash flows comes out to be 207.899 lakhs. Okay. Okay. So this is one type of problem. Then there is one more, complicated version of this problem that I came across. We'll just take that so that it becomes quite clear. Okay. So there is, for another project, the details are as follows. Okay. For a project, initial cost is, let's say, 220 lakhs. annual operating cost is 15 lakhs per annum. Cost of renovation, there is now they have something called as cost of renovation, which is another expenditure, is 24 lakhs at the end of every 15 years. Okay, and then you have one-time upgradation cost, which is nothing but around 30 lakhs at the end of 20 years. Okay, so find the capitalized cost at 8% interest rate. Okay, so this is the problem. Now if you look at this problem, the thing is, if you compare it with the previous problem, uh, these things are same only, right? So we know how to compensate for these factors. But the interesting that comes out is this one, that there is a recurring cost. Okay, this is not annual cost. It is happening every 15 years. Okay, it's not a recurring or annual cost. It's a recurring cost, but the frequency of recurrence is 15 years. Okay, so now how do you take into account that fact? That is the main question. Okay, so just because other things are known, this for renovation cost, you need to find its present worth. Okay, because this capitalized cost is nothing but present worth only for various cases. Okay, so what is it about? So let me just give you a simple formula. So let's say you started, then you are at 15 years, 30 years, 40 years, so on and so forth. And every time you are you are supposed to do the renovation with expenditure of 24 lakhs, right? So this will be your cash flow diagram only for renovation cost. Okay. So here, what will be the present worth of first 24 lakhs? You need to discount that back to the present. Okay. So that will be P by F 8 comma 15, because interest rate is 8. Similarly, you have to do this for P by F 8, 30, so on and so forth. Okay, for infinite times. Okay, so this is an infinite series. So now you can take 24 common. So what is this P by F I n formula factor? I mean, this P by F I n factor is nothing but I plus 1 power minus n. Okay, so that is the factor. So if you take 10 common, what you end up with is, if you take I as 8 here, so that will be 0.08. So this will be 1.08 raised to minus 15 plus 1.08 raised to minus 30, so on and so forth. Okay, so next term will be, just for the sake of completion, so that you understand, this is a geometric series, minus 45, so on and so forth. Okay, so now you need to find the sum of this geometric series. Okay, so this is the infinite sum. So, and the common ratio is 1.08 power minus 15, which is less than 1. So it is a convergent geometric series. So the summation will be a by 1 minus r. So first term is 1.08 power minus 15, 1 minus r. R is the common ratio. That is also 1.08 power minus 15. Okay. Right. So you need to find this value. component of that innovation cost in your capitalized cost or CE. Okay. So you know, what we can do is multiply by plus 15 everywhere. Okay, so this will become 24 into 1 divided by 1.08 power 15 minus 1. This is easier to calculate, right? So that's why I did it. Okay. So let's find this value. 24 divided by 1.08 raised to 15 minus 1. Okay, so this comes out to be 11.05. Okay, so this will be lakhs because all the values are in lakhs, right? So now we can calculate the total capitalized cost or capitalized equivalent cost. So initial cost that you have to put is 220 lakh. So that is as it is because that's the present worth of initial cost. Then your annual maintenance cost is 15 lakhs that you have to divide by I, that is 8%. And then cost of renovation that comes from here, that is 11.05, plus you have one major one-time upgradation cost, right? That is 30 lakhs at the end of 20 years. So you have to discount that to the future value. So that is nothing but discount that to the present value. So this will be P by F 8, 20. Okay. So this factor from the table, P by 8 20, right? So that is 0.1486. Okay. So if I do these things, okay, so 30 into 0.1486, that is around 4.45 lakhs, plus 11.05 plus 15 by 0.08. Okay. 1 second. So uh, you have 30 wala term is there, 11.05, 15 is there, and then you have to add this 220. So the total cost that comes about is you know about 423.008 lakhs. Okay, so this is your answer. So this much capitalized cost you should have on your books today, so that you'll be covered for the various future expenditures, etc., that you have to incur. So the main thing is this one. Okay, so this one was the different thing in this problem that you should be aware of. So you can't use this A by I formula if the recurrence is not 1 year. Okay. So if it is annual recurrence, then A by I formula is okay. But if it is not annual recurrence, if it is 10 years, 20 years like that, going up to infinity, then you have to use this formula. Okay. So this is should use. Okay. So I think with this we covered mostly the concepts. This this project balance, it was taken in the class only, right? So that's why I'm not. I mean, since we are out of time also. 1 second. Yeah, sorry, because there was a emergency call. Anyway, so yeah, this last thing is about this, this what do you call this project balance chart, etc. is there, but I think those things are taken by professor, so I don't want to take same thing again and again. It is more or less uh, doing this same thing only what we did here. Uh, this for payback period calculations, but the only thing is they don't take uh, this minus 80 as constant. What they do, whatever PW that you get at the end of 1 year, the same thing is discounted at some interest rate next year, and then not discounted, it's basically compounded plus the cash flows that appear next year, like that they do. Okay, so it was quite uh, you know it was discussed by the professor in quite detail, so that's why, and there is nothing much I can add to it. Okay, so this project balance diagram, this project balance, you can call it diagram or chart, whatever you want to call it, but the only difference that we did in the previous problem, which one is this one, here we are just discounting the cash flows to the present value. uh, in this project balance diagram or plot or chart, okay, project balance chart, they don't do that way. What they do is they just keep on compounding your uh, cash flows to the current year. Okay. So you can refer back to that formula since we're at the end of our time also. Basically, you will have PB for certain interest rate at certain time t, that will be 1 plus I into PB of the previous time step minus 1 plus whatever the cash flow that is happening at the current time steps, and your t goes from 1 to n. Okay, so that is the recurring relation that you use to calculate PB value, which is project balance value at every time step, and then you'll get certain plot like this. Okay, so you may, I mean, depends on the cash flows actually, but you certainly initially you will in the negative region somewhere, and then eventually you end up in a positive side of the region, because that is where your project is feasible, right? Otherwise, if you're always on the negative side of your uh, cash flows, then this project is not uh, worth pursuing, is what it means. Okay, so maybe something like this. Okay, this is one sample. Okay, so something like this. So this will be your uh, right. So what you have here is, this is just a schematic. So this is your time axis, 1, 2, 3, 4, 5, like that. And this is your project balance amount axis. So PB of, or PB subscript T should be the correct notation. Okay, so this is your time axis, and you get a lot of information from this. You know, for example, when you turn, uh, you know, so in this region, your PB is negative, right? So your uh, you know risk of loss is still there. If your project gets terminated before third year, your risk of or exposure to loss. So this, in this project, you should make sure that you continue this project till the year end 3, where it crosses your to the, from negative to the positive side, right? So this is your negative, and this region is your positive region, right? So here basically it means profits on this. So these are your uh, equivalent profits. Okay, so, and this is your turning point. Okay, so this is where your project becomes profitable. So at least for 3 years it should run. Okay, so like that you have to make calls. Okay, so this is about all these things. So with this we'll stop for the day, and we'll see you next time. If you have any doubts, you can join the next class early, and then we can discuss. Otherwise, we'll see the the concepts of week 6 in the next.